Okay, so this little lesson is just going to introduce us to the basics, the most important parts of what we're going to do this week. So what we're going to do this week is something called factoring, and think about it as like the opposite of multiplication. So multiplication, we've learned how to solve questions like what you see below. Anytime you see parentheses, you're going to distribute. And we also know that when we multiply, exponents are going to change. So when I multiply and distribute here, I'm going to get 10x squared. And then when I multiply the next part, 5 times negative 3 is negative 15x. All right, on the bottom, we've seen one like this before. Remember, that means we have to distribute twice. Or for some of you, that means that you draw the box. Either way, we're going to get the same thing. So the first multiplication, we're going to get 2x squared, because we have two x's there, minus 3x. And then the 1 is going to multiply, so plus 2x minus 3. And then, as you've learned before, we're going to go back and combine some things that go together. So these both have x's, so I've got 2x squared minus 1x minus 3 is my answer. So everything we've done so far, they give you a multiplication problem with parentheses, and they ask you to multiply it out. Factoring is going to go the other way around. They're going to give us the answer and ask us what the multiplication problem would have been. So let's look at a few of those. Okay, so we're going to do two easy examples. To factor is to undo multiplication. So like we said, we're going to be going backwards. So because we're undoing multiplication, we need to think about it as if it's division. So what we're going to do, each time you need to think about the number of terms you have. So remember, terms are like the number of pieces. So question A here has 2 terms. And I'm trying to think to myself, what is the biggest number that I can divide into both of those? So first I'm just going to think about the numbers, negative 4 and negative 8. What is a number that divides into both of those? Well, 2 goes into both of those. 4 can go into both of those. I want the biggest one, so I'm going to pick 4. I'm actually going to pick negative 4 because this first number is negative. All right. Now I also want to think about what's the biggest number of x's or variables that can be divided by both of those. And that's kind of the way I'm saying that probably sounds a little bit weird, but what I'm really asking you is what's the most amount of x's that you could take out of either term? I'm not sure if that's going to make sense, but the answer is that you could take 1x out, right? You can only take 2 x's out of the first term. You wouldn't be able to take 2 out of the second one. So it has to be the number that you can take out of both of them, which is just 1x. Okay, so because I'm dividing by negative 4x, when I write my factor, that becomes my first term. So negative 4x is what I would have multiplied by. Think about multiplication and division are undoing each other. This first number, this negative 4x, is called my GCF, or my greatest common factor. Greatest because it has to be the biggest, and common because both of them have to have it. And then to figure out what is in parentheses, we actually have to do the division. So we're going to kind of focus on one problem at a time. So if I kind of focus just here on this part and I divide, negative 4 divided by negative 4 is 1. And x squared over x, remember one of those x's is going to cancel, so that's just 1x. All right, then if I go and I focus on my second problem, remember I'm dividing because I'm undoing the multiplication. Negative 8 divided by negative 4 is positive 2. And x divided by x, those just cancel each other out. Which means what I have written at the bottom is now my final answer. And we can always check that by multiplying. We always should check that by kind of multiplying back out. Remember, we think this would have been the problem to begin with if what they gave us was the answer. So let's make sure that's true. If I multiply negative 4x times 1x, I get negative 4x squared like I have right here. If I multiply negative 4x times 2, I get negative 8x, which means my answer is in fact true. All right, let's try one more. So remember, we're going to start by thinking about the greatest number I can divide into both of them, because I'm trying to undo the multiplication. So I want to think about the greatest common factor. So what's the biggest number I can divide into 10 and 25? All right, hopefully you're coming up with 5. And now I also want to think about any variables. Is it possible to take out any common variables between the two terms? Well, the first one has an x squared, but the second one doesn't have any x's. So I can't take any x's from both of them, which means I'm ready to now write my answer. So again, just like in the previous example, my GCF, what I'm dividing by, goes in the front. So that's this 5 number that I divided into both of them. And then I get the numbers in my parentheses by actually doing the division. So I'm going to first divide this first part. 10 divided by 5 is 2. And I have x squared. All right, now I want to go back and divide this second one, which is 25 divided by 5. And 25 divided by 5 is going to be positive 5, so plus 5. And just like with the last example, we always have to go back and check and make sure that it works. We check it by multiplying. Remember, we think this is the problem that would have given us the answer. So if I multiply, 5 times 2x squared, is that 10x squared? Yes, that's right. 5 times 5, positive 25, that's right. So what I have is, in fact, my final answer. All right, we'll do one more example just to make sure that you kind of see the pattern that's going on here. So remember, we're going to start. We're trying to undo multiplication, so we have to think about our division. And we have to ask ourselves, what's the greatest number I can divide into each piece? So I'm thinking about 6, 4, and 2. What's the biggest number that divides into all 3 of those? And you should see that it's 2, so I can divide a 2 into all of those. And then when we think about our variables, we want to think about what's the greatest number that I can take out of every single one. So I know that, like, you may see that this one in the middle has 3 x's, but I can't remove 3 x's from each piece, right? That's not possible because some of the other pieces don't even have that many. So the greatest that I'm allowed to remove from each single one is just going to be 1x. Everyone has at least 1x that I can take away. So that's going to be my common factor for my variables. Now remember that first, what you're dividing by, goes in the front, so that's 2x. And then we need to think about and do our division to figure out what would have been in parentheses to start off my multiplication problem. So I'm going to actually go back and divide. So if I look at my first piece here, if I do 6x squared divided by 2x, 6 divided by 2 is 3. There's 2 x's on the top and 1 on the bottom. That's going to cancel out, so that just leaves me with 3x. All right, now if I go back and I'll do my middle piece here. Negative 4 divided by negative 2 is negative 2. There are now 3 x's on the top, and we're taking 1 away, so that's x squared. In my last piece, I've got positive 2 divided by 2, that's just 1, and x divided by x cancels each other out. All right, so now remember, the last thing we always want to do is we just need to check, kind of do a mental check and make sure that we haven't messed anything up. Make sure that when we multiply, we still get the original problem. So if we multiply here, 2x times 3x, that's 6x squared. Okay, that part's right. 2x times negative 2x squared. 2 times negative 2 is negative 4. And that should give me x to the third, which is what they had in the original problem. 2x plus 1, that's going to give me 2x, which was also in the original problem. So I know that my answer is correct. You may need to go back and rewatch one or more of these examples because this is a very basic fundamental skill that we're going to have to use going forward. So you need to have this skill.